Guys, I'm really sorry I have to do this, but I've just redone all the algebra, and I have to do a small correction to the previous video. So, there's a few problems here. I'm going to tell you in a moment. First of all, I'm going to correct this. So, we don't have a 4 here. And then there's a 4 here. Okay, maybe I'm gonna get rid of this and aspect ratio squared and a 4 dividing that. Yeah, I'm sorry about that. It's just that, you know, in the expression in OpenRocket, that was a thing that I just confused their definition of span, which is S, is like the semi-span for me, which is B. So S is B over 2 for me. And then, yeah, I messed up something with that, you know. Then the definition of the area of the fin is a different definition of the one I did. But yeah, I just made sure that was right. And if you want to do the derivation by yourself, yeah, just note that if you want to check it, my calculation. But I'm pretty sure of it right now. I checked with the ones that I get from OpenRocket, and it's good. This sweep angle is not the sweep angle, the leading edge sweep angle. Okay, it's the average kind of sweep angle. Let's see if it's this one here. So you have to do some some geometry over here, and you'll find that basically if you start massaging the equations, you'll find that this angle here, well, the cosine, after doing a bit of work, you'll find that the cosine is this. Let's see if I get it right. Just 2 over aspect ratio. And then we have, as you know, I'm always going to try to non-dimensionalize stuff, because then we can, you know, it's easier to design. Okay, and then this is squared plus 1, and all this is power minus 0.5. Okay, so you can get that out of geometry. Okay, so it's purely geometrical. It's kind of tedious, but you can find it. So we're finding this angle here, and here is half the half the chord of the root. Yeah, just in case you wanna check my algebra, but I'm pretty sure now. So okay, yeah, and this is, of course, the leading edge angle. So yeah, you have to play around a lot with geometry and the variables and everything. So finally, you will arrive here, and this is correct. Last check. Well, no. With that change, this is going to be over 2. Sorry for this. It's just, you know, so much algebra here, and it's easy to mess up. All right. I'm pretty convinced right now. So, I'm sorry. Maybe I'm going to retake all the conclusions I got out of here. Anyways, I showed you how to put it into Mathematica. I'm gonna do it again. Oops, laggy. I'm gonna do it again just in case the conclusions are very different from the ones I gave you on the last video, but you can do it yourself in Mathematica. Plot out this function and see what I did basically on the last video, so it can aid you with the fin design, right? And remember this. I don't know what CF stood for, but this was this depended if we had 3 or 4 fins. This is equal 1. If we have 5, well, it's it's those parameters we found in. Okay, here. It's these parameters. I call this the CEF. Don't know why. Okay. And now it looks good. Yeah. Good. So I'll recheck all. Say if I just concluded something crazy. I think I didn't. It didn't change that much, the value. Hopefully. So order of magnitude was similar, but I was doing some napkin calcs, and some things were kind of fishy. So I just redid all the algebra and the geometry, and yeah, I did a small mistake. But yeah, unless the conclusions are way off, I'm gonna leave it to you. This is just an overview of the effects of the parameters. So just remember the aspect ratio is going to have it's going to be a big actor in this capital Pi correction factor. And maybe I'm going to try to do a big simplification of this, so we can get maybe I'll look into that, and maybe I'll do a video on that. We can simplify this quite a lot, because if we have sweeps of from 30 to 50 degrees, which are typical sweeps, you're probably not going to go over it, because if not, you get the sweep penalty, which I'm pretty sure it still happens in this corrected equation. And then the taper ratio, it doesn't affect too much the CN alpha if you have same specific span and same aspect ratio. So it's kind of relevant unless you go really down, which is delta wings. So unless you don't have delta wings, so a taper ratio of 0.2, this doesn't influence too much. So what I mean is that this is kind of mostly function. This is kind of mostly function of the aspect ratio. So what I'm gonna do maybe is, this is kind of like a power. This can be like a power function, more or less, in aspect ratio. So yeah, to see if this correction factor, well, if we can make a big simplification for parameters that we're probably going to use. So yeah, we would go from 3 variables to 1 variable in the correction parameter, which is nice. So maybe I'll do that.